Hello everyone, welcome back. So this time we're going over the group problem. So if you're doing this right now, grab a parent, grab a sibling, grab a friend, and see if you can do it together. So what are we doing? Well, we have a 2D force and couple system is shown. This time we actually have a couple moment. So don't forget that. We're going to try to figure out the equivalent resultant force and couple moment acting at point A. Okay, so with that in mind, let's try to solve this. First off, what we're going to do, we're going to sum all of the x and y components of two forces to find the resultant force at A. And then we're going to find and sum all of the moments resulting from moving each of the forces to A. Now, we're moving them in a horizontal distance, so in the end, only the vertical component will matter of the forces. So, I should stop. Almost gave it away. Remember, now you're going to pause, you're going to try it on your own, and then you're going to come back in a few minutes and you'll see what you did wrong, what you did right. We'll do it together. So 3, 2, 1. Okay, so you should have paused, you should have done it. If you haven't, shame on you. Now let's try it out. So first off, sum of the forces. We have 3 forces, we add all their components together, being very, very careful about how these angles are specified. So 30 degrees right here. Okay, if I write this like this, what can get confusing is that the 30 degrees is talking about that angle right there, which means that I'm using sine of 30, not cosine, to get the x component, and cosine of 30 to get the y. For this one right here, luckily the angle, that's what we're kind of expecting, is this one right here. It's to the x-axis. And so this x component we get using cosine of 60. And for the y component, we use sine of 60. And this one, just pointing straight up and down. So we add all those together and we get our forces, which are both negative. And now we got to figure out the magnitude and direction of that, because that does matter, because you can't just say, well, they're all going to be straight up here. They won't. They'll be at an angle. So we take the magnitude, which is just Pythagorean theorem, and then we use our inverse tan function, y over x, to get the angle to the x-axis, which comes out to be 84.5 degrees. And finally, we need to find that moment. So we take the y components, only the y components, and multiply those by the distance we're moving in the x direction. They all have the same direction. They're all pointing down. So we don't really have to worry about sign too much here, but we still need to remember that counterclockwise is usually considered positive. In this case, though, we're considering clockwise to be positive, but you can choose what you want to make sure you're consistent. So we add them all up, and we see that we have 9,535 Newton meters, and that's going to be clockwise. Also notice that we added on the 1,500 Newton meters to that. We have to add into that when we're calculating our resultant moment. And that couple moment, even though it looks like it's applied at the end, can be moved anywhere because it's a couple. It's a free vector. It can do what it wants. Last thing we need to figure out, that's what I had to do. Sorry. I was going to go ahead and start figuring out what distance we had to do to calculate how we can make this into a single force. You can do that if you want. In fact, let's do it. So, we have a y component right here. And we have our moment right here. If I want to find the place where I can move everything and have that same moment from a resultant force, then all I have to do is divide the two. So 9,535 divided by 1,296. I'm not going to do the math here, but you can figure that out, and that's going to be, just guesstimating here, around 8. I'm going to go with 8. Around 8 meters. Somewhere around there. I'm going to be a little bit off, but that's roughly where I can put all my forces to get that same thing. So I put my sum of my forces to get the same exact effect. Okay, with that, we'll stop here, and if you're still struggling, we've got one more problem to do together, and then we'll call it quits. So, I hope this helps you, and I'll see all of you next time. Bye-bye.